I'd like to talk a little bit about tension. So you'll see the word tension a lot, and I just want you to remember that tension is a force. It's usually going to be the force exerted by a rope or a wire, or basically any object that pulls on one another. But in the situations that we're going to be doing today, it's going to generally be a rope or a wire or something like that. So most of the problems that we're going to do are going to involve objects that are hanging from wires and then finding the tensions in the wire. If you see that type of thing, the way that you're going to find out the tension is by remembering that the sum of the vertical components of tension in each wire is equal to the object's weight. So first example, we have a picture that has a mass of 1 kilogram. This picture hangs freely by 2 light strings attached to a hook above the picture. Each string forms an angle of 60 degrees with the top of the picture frame. We would like to find the tension in each string. Now, thankfully in this problem, we do have the same angle, so the tensions in the 2 strings are going to be the same. If they were different angles, they would have a different amount of tension. First thing we need to do, we need to take that our mass is 1 kilogram, use that to find our weight. So our weight is going to be either 9.8 or 10 newtons. I'm just going to use 10 just to keep it simple. That is my downward force. So what I'm going to do right now is break up my my strings into two separate triangles. So the one on the left, I'm going to call that T, and actually the one on the right I'm also going to call T. So this is my left string. I know that my right string is equal, so I can just write T for both. The other thing I know is that this angle is 60 degrees. Here's the last thing that I know. The last thing that I know is that the tension, the vertical component of the tension in each string is going to be equal to exactly half of 10 of the weight. So each string is going to have a vertical component of 5 newtons. It's really important that you get that correct. Otherwise, you're going to get a really weird answer. So keep in mind that the vertical component of each string is not necessarily going to be the weight of the object. All of those components are going to add up to be the weight of the object. And once we have this triangle right here, all we're doing now is some trigonometry. We're going to use sine because 5 is our opposite, t is our hypotenuse. So sine of 60 is going to be equal to my opposite over my hypotenuse. If I rearrange that, I get that my t is equal to 5 over sine 60, which gives me a tension of 5.77 newtons. And that is going to be the same for both strings. Example number 2 is quite a bit harder. So we have a bird that lands in the middle of a clothesline that's stretched between 2 poles that are 4 meters apart. It causes the clothesline to sag 4 centimeters. We would like to find the magnitude of the tension in the wire. So I'm first going to tell you that my drawing is definitely not drawn to scale. I started by converting the 4 centimeters to meters. Don't forget to do that, otherwise you're going to get something really strange. So when I have a problem like this, I have to do a few things. The first thing is I need to find some angles. Once I have that, I am going to have to work with forces. So right now I have distances. I cannot convert between distances and tensions or distances and forces What I can do is I can find the angle, use the forces that I know, and I can use that to find other forces. So I'm going to start by drawing this triangle. This is going to be the right half of the clothesline. This side right here is 0.04. This side up here is 2 meters. Keep in mind this is half of 4. I do not know my theta, my angle there. That's going to be this angle right here, by the way, but I can find it using tangent. So I end up getting that tangent of that angle is the opposite, which is 0.04, over the adjacent, which is 2. That gives me an angle of 1.146-ish degrees. Really, really small angle. Like I said, this isn't drawn to scale. So that angle is actually going to help me out quite a bit. So you'll notice that I only worked with my distances in that previous part of the problem. Now I am only going to work with forces. I'm only going to work with tension. So tension is a force. The force due to gravity is a force. Weight is a force. So we're going to actually find the only force that we really are able to find right now, which is the weight. So the weight of the bird is, keep in mind, it's going to be mg. You are welcome to use g equals 10. I end up getting that the weight of the bird is 40 newtons. So at this point, it's important to remember that we're going to have to split up our clothesline into 2 parts. So the right side on the clothesline, I'm going to call that tension T. I know that that part of the clothesline has a vertical component of 20 newtons. The horizontal component we don't know, and actually we're not even going to bother finding it. We don't actually need it. You can find it if you really want to. Keep in mind the 20 is for this side, by the way. So I know the angle, I know the opposite side. I now just need to figure out the hypotenuse. And that's going to be using sine. I get sine of 1.146 is going to be equal to my opposite side 20 over my hypotenuse, which is t. I'm just going to do t equals 20 over sine of 1.146. And I ended up getting that it was approximately equal to 1,000 newtons.